started to say accidentally before the break, we deliberately had a much more concentration of Japanese speakers this year to have you understand how much momentum we've gained over the last year. But of course, we know that you still have interest in what's going on globally. So we had the great presentation from Matthias before break. And continuing along those lines, then let's bring up Chris Day, Principal Sales Engineer with MarkLogic. And I don't want to embarrass him, but he was the Sales Engineer of the Year at MarkLogic, which is a company full of very, very talented and smart sales engineers. So that says something. And so he'll be sharing with you sort of a broader view of what are the latest and greatest types of data challenges that we're solving globally and how we're making that happen. So please welcome Chris Day to the stage.
Thank you, Denise. Welcome back. Thank you for coming back to spend some time with me so I can talk about how MarkLogic solves complex business challenges. And I do emphasize the complex piece of it because we're all around solving challenges that matter. We're not after the trivial, we want the big challenges that matter. So my name's Chris. As Denise has introduced me, I'm from Sydney, Australia. And in Australia, I work with customers to help them solve problems, primarily in the financial services, so banking and investment, as well as the insurance industries, but also involved with customers and in public service and also in transportation. So once again, thank you for agreeing to spend this 50 minutes with me, but I would encourage you to stay after I finish so you can hear Joe Pasqua, our Executive Vice President of Product Management, so he can fill you in on what's actually coming in MarkLogic version 9, which is very exciting. And then after Joe finishes, I look forward to meeting many of you and having a discussion with you at the reception later this evening. So once again, thank you. But I just want to start this out by having you consider this as your information landscape, this highly distributed, totally disconnected, hundreds of silos of data. And this complexity within organisations has come about both because we're trying to solve complex business problems, a fact of the technology that we're trying to use, that our customers are demanding more and more from us, faster and cheaper. And so what ends up happening is this complexity comes about because we put in all these point solutions. Now consider that you want to look across all those systems to get a view of a customer. Where is that view? You'll probably find that it's just distributed. Each system has its own little section. But is that any good? Does that really give you a true view of that customer and the value of that customer to your organisation? Wouldn't it be better if the view of your customer was complete, consistent? And then you can see both the value of the customer to your organisation, as well as what your customer wants, how they want to interact with you, when they want to interact with you, what products they want, what service they want. And it may be that your organisation isn't interested in customers, and that can happen. I mean, it may be that you're a financial services company and you're interested in trades and trends and futures and so forth. Or you might be a medical services company and you're all about medical trials and the efficiency of drugs in treating disease. Or how about in manufacturing and just wanting to get product recalls, understanding the life cycle of a product, where that product's being distributed across your customer base, how to do a recall, how to do that recall effectively, and know that you've in fact got all of the defective products back from the market, or at least that you know where they are. Or even to the point that you just want to detect fraud, or potential fraud, or fraudulent activities. Not necessarily that you want to go out there and convict everyone of fraud, but you just want to be able to detect it. Now, all these situations have one thing in common. They all require a complete, consolidated view of your data, not a disconnected, disparate view across many silos. And the other thing that they've got in common is that we're not building this view for a backward-looking view. We're not here just to put them into a warehouse, just to run a report, put them on an Excel spreadsheet and put them in the cupboard. This is all around using this view to make decisions, to make business decisions that matter and that actually solve complex problems. So how do we do this? Well, what we can do is we'll start right from the beginning. And yes, I know it's very simple. What we've got here is what they call an entity, and I'm sorry for the non-techies in the room, but we're going to be a little bit techie for a while. We've got a very simple diagram here that demonstrates or illustrates the relationships between a customer, a transaction, and a product. And all it's saying is that a customer can have many transactions, a transaction can have many products, and products can be on many transactions. So it's very simple. And just bear with me, because even though this is a very simple example, and we could substitute customer for trade or product or any entity that you want to, I hope that as we step through this, we'll illustrate how MarkLogic can help to solve those complex problems that you have. So this is just a model. It doesn't do anything, it's just a representation. But what we actually do is implement this model. Now in our traditional relational world, which we're all very common with, we implement this model as tables, or a schema within a database, and a schema has tables, and so on. But while this is a physical representation of our entity model, it doesn't really tell us much. I mean, it says, okay, there's customers have transactions have transaction lines, and transaction lines have products, and so forth. But what it doesn't tell us is, well, what does ADDR mean? I mean, we could guess, is that the full address? Is it one line of the address? Is it the billing address? Is it the home address? It doesn't really matter. It's just not clear. But what we could assume is that because there's actually city and state, that the address is just the first line. But that's an assumption that I'm making. Oops, we're going. Yeah, that's an assumption I'm making. The data is not telling me that. All right, and that's just one physical implementation of that relationship model we were talking about. Let's have a look at the second system. Oh, it looks pretty simple. There's only one table. But what about phone? Oh, it's not storing phone numbers, and it's not storing the actual products. Okay, so let's explore further. And okay, so this is where we store phone numbers. And you can see, even though we're talking about the same thing, we're still talking about customers, still talking about addresses, still talking about phone numbers. It's very, very different to our first schema that we put up there. And then as we drill in further, we can find out more information. And it's actually quite a lot more complex than our first model. And as we drill down, we can even find that we're starting to talk about suppliers. Well, our original model didn't talk about suppliers, so what do we do that? How do we use that to answer the question? And this becomes even more complicated when we try and put this together. So we're trying to build that consolidated, or that 360-degree view of a customer. We've only got two schemas, and they're very, very simple schemas. What happens when our schema looks like this? I mean, imagine the pain that we have to go through. And this is what happens in the relational world, is that before we even start looking at data, before we start even ingesting data into the database, we have to make these sometimes quite complicated decisions, and even to the point that we have to decide what we're going to leave out of the database before we can even start to put data inside the database and do things with it. So if we go back to our two schemas, what we're going to try and do is assume that we're in a relational world, because everyone's comfortable with that, and we're going to start to build a model that we can do to get single customers. So the first thing we're going to do is, okay, we'll simplify it. So we'll take out the phone numbers. And okay, we don't want shipping addresses, so we'll just get rid of that. And what would be even simpler then is, we'll just remove the phone number table completely, because as far as we know now, the questions we want to answer right now, it doesn't involve phone numbers. That's not to say that we won't need them later, but now. This is how we're simplifying the whole argument around building that view of a customer. So what we end up with is, again, a schema, and then we have some new requirements, so we build another schema, and then some new requirements come in, so we build yet another schema, and lo and behold, or I don't know if that translates, I'm sorry, but congratulations, you've just built another silo with an entirely new super schema, but it is another silo. It's completely separated from the rest of the business, which means that we're now locked into this row and column world. Everything has to fit in. There we go. Everything has to fit in a row and column. If it doesn't fit in a row and column, we drop it on the floor. So how does MarkLogic help us with that? And how can we add value to the data that you're actually using, the environment that you're working in using MarkLogic, so that it's just not a problem about which data we leave behind because we don't understand it or it just doesn't fit. So we go back to our relational world with the the Frankenstein schema, or what did you call it before, Gary? The Frankenbeast, yeah. It's a new marketing term I hadn't heard before. And what we do is we actually look at some alternatives. So how can we do this but still build a reusable, canonical, or application-independent model, such that it doesn't matter what the application is we're building now for, but in the future we can still leverage that model. So it's a case of building the model for reuse and keeping your data, not dropping data on the floor. How can we understand the lineage of the data that we're putting in here? Where did the data come from? How did it get there? What's the value? What is the context of that data? What actually happened to that data before it got in there? And then all of this is in a changing environment. Everything changes. I mean, today you've given me a set of requirements for a report. Tomorrow you want a different report. Things change, constantly change. So how do we do this, but in a changing environment? And yep, there we go, changing environment. So, and the answer basically is MarkLogic. But what we end up with is an application-specific set of data coming in, but a canonical, reusable, valuable, agile model coming out, as well as being able to preserve the provenance, the lineage, the governance of all that data as it flows through. So we're talking here about an operational data hub or an operational data store, but something that takes that constant or that disparate, fractured view of all your data, puts it into one place, manages it, and gives you a consistent, complete view for reuse. And we do all of this, but still providing you a highly flexible, agile platform. So hopefully, well, no hopefully about it. I will take you through the steps with our little model, our little schema, and we'll actually show how this can be done in MarkLogic. So if we go back to our tables, this is our first schema. What actually happens is when we go through the tables and get a row out of the table, so navigate all the different tables and get out a row, we end up with a row. It's just a row of text. And already we can see that some developers been cheeky about it and cheated on the schema because they put 2 phone numbers in the phone number field, where in fact our model only says 1. Okay, so already we've got a data quality problem. I don't know if you can see that across the top there, we've got phone with 2 phone numbers in there. So then if we go and have a look at our second schema, so this was the more complicated one. And it turns out that in order to get a order or a transaction out of the schema, we've actually got to put it all together. So, across 5 different tables, we end up with 3 rows, 5 rows across 3 different tables. So it's quite complicated. And the other thing about that is that relationship between all of those tables, that's not in the database. That's in an application somewhere. So if you're not sharing that application, how do you figure out what the relationships are? But we'll come to that a bit later. So if relational is so hard, well, what's the alternative? Well, the alternative is MarkLogic using a document model. So here we've denormalized, so we've put all those rows and columns back together and put them into a single document. A single view of the document. It's simple, it's human readable, it's known, it's self-describing, it's dynamic, it's agile, all of these keywords that we're looking for in our environment. And you can see that we've got two different ones, but they're in the same database. It's not like we have to go and prepare the database and say, well, this one goes over here and this one goes over here. How did we get here? Well, if we have a look at the relational world, we had to put all the schemas together. We had to figure them all out, figure out what all the relationships are, what all the data actually meant. Then we actually had to decide what we're going to cut out. We have to then build the new super schema or our new extra silo that we're putting over to the side. Write a whole lot of new ETL. If it comes up. That's all right. And then finally, we can load some data. So we've done all of that, and we're only just now loading data. How does this work with MarkLogic? We grab some sample data, we put it into MarkLogic. Already, we've simplified the whole thing. Really, really easy. So, and I spoke about modeling. So how do we start to do modeling within MarkLogic? Well, one way of doing it is using a canonical model. So an application-independent model. Now, we've got our two documents here. We've got our two transactions. But we can start to enhance those and put the model on the top. So now when we want to ask standardized questions such as zip code or postcode, we can now ask the question, what is the zip code? And you can see that for our first one, we ask the canonical section of it and we get zip code. And for the second one, we actually get both the billing address and the postal address. And even though we've just asked for one thing. And this can go on. So already we're faster getting data in. It means that we only actually have to harmonize or model the data that we want. The remainder of the data can stay as is, and we can still query it as well, but it can stay as it is. And then as we find out more information about the data that we're using, we can continue to enhance that little canonical piece at the top. We can continue to build that model. And it can be updated on the fly. The other thing we can do in here is start to talk about lineage and provenance. So we can enhance our documents again and add metadata in it about where the data came from, when it came from there, how it got there. And so all this without actually touching our raw data, but it means that we can now ask questions of our data that we couldn't, that are very difficult within the relational world. Because the only way we can start to track this in a relational world is have another table. And what happens when we change things? Well, then we've got to have another table to track the changes to the first table. And it just goes on and on and on. But now with MarkLogic, not only are we getting data in there fast, and we're able to dynamically update the model, but we can now query and preserve the metadata associated with the actual data right in the same database. And what happens when we want to put new data in? Well, as we said before, we can put two documents side by side. They're totally different structures. It doesn't matter. It's the same with the canonical model. Say, for example, we had a new requirement to track Twitter IDs. I don't know if you'd want to track Twitter IDs, but okay, so we've got some Twitter data coming in. So we go through the same process. We can put an envelope around it. We can start to actually build some metadata around it. And you can see that we've also put the canonical piece in here. So we're starting to model this data. And the thing to note is the model for the Twitter data is totally different to the model for the customer data? It doesn't matter. We can do both. We can query both. We can enhance both. We can learn about the data and enhance that. So now we've got data in there. What we've actually built is a view of an entity. We've actually built a view of our customer or an entity using a document within MarkLogic. All good, all very easy, without doing any ETL, without doing any planning up front, without having to worry about what data source is coming in, all done. If we go back to our schema again, we'll see also that there's relationships in there. Now remember before I said that those relationships are not firm. It's up to the application to enforce the relationship. So this is a whole heap of potential relationships just by me looking at the data. But if we actually have a look at an application, well, these are the actual relationships. So it's a little bit simpler, but you know, if I had to guess, what's the problem? Now, if we take that and put it across our document model, we can see that we can still build those relationships using the document model. So we could leave it as is. But what this isn't telling us is what the nature of those relationships are. All it's telling us is that there is a relationship. It doesn't tell us that this product was bought by this customer, or this customer bought this product. It doesn't tell us that relationship. That's an application thing. But what it has done is enforce this, or help us view this entity model. The thing we can actually do is start to describe those relationships within MarkLogic using triples or RDF. So it's basically a string that describes a subject, a predicate, and an object. It describes a single fact about something. So in our example, we can build 3 triples, 3 threes. So one triple says customer 2001 placed an order 8001. Order 8001 contains a specific product. But when we put those together, those triples together, we build a graph, and then we can start to query that graph using Sparkle. So that's another language that runs within MarkLogic that allows us to navigate the graph. And we can now ask, select the customer, where a customer placed an order, and an order contained a specific product. So that would allow us to nominate the graph, to navigate the graph. But the other thing we can do is start to build semantics into it. We can start to describe that relationship, whereby if we know that when a customer places an order and an order contains a specific product, we can then infer that a customer bought a specific product. So we can now, without actually physically putting it into the database, we can now describe that relationship to the database, which now allows us to run a query to say, give me all the customers that purchased a product. Okay? A known, defined relationship. And we can then continue to, just like we were doing with putting the data in and building the canonical model and adding the metadata and the provenance, this concept of semantics can continue to grow and be enhanced, in that our simple model here could then be further enhanced, where we're starting to add definitions and we're starting to add other relationships, such that, you know, product 702 is a power supply. 7002 complements 7001. So 7002 might be the power supply and 7001 is the laptop. So they go together. And then we can say, you know, you could put comments on the actual relationships themselves. But what this allows us to do is to start to ask very complex and targeted questions of our data, with the database actually enforcing those relationships rather than the application enforcing the relationship. It also allows us to put that business language, those business relationships, inside the database, where not only are they human readable, but the database can also leverage those same relationships. So we're putting things together, so they're all in one spot. So now what we've done is we've got entities as documents and relationships described as triples. We've got firm, described relationships, rather than relationships that are guessed at, or possibly like this if we do it on a Tuesday type thing. So who's doing this? Well, we've heard this morning of many different customers that are using MarkLogic in order to solve business problems, whether they be from financial services customers, or whether they be in legal customers, or even some military customers. They're all using the abilities of MarkLogic to bring together silos of data to answer specific complex questions. What I'd like to do is just talk about some other customers that are also using it. One in particular is a customer that uses MarkLogic in order to bring together disparate views of data that quite often can't be shared for privacy reasons. So we're talking here about child protection. So I'm sure you could understand that some children are at risk, and this data just cannot be shared. But using MarkLogic, we're able to build a consistent, consolidated view of all the information and get an understanding of what the risk is. And a customer that did this is in the UK, the multi-agency safeguarding hub in conjunction with the Staffordshire Police. So they built a system that consolidated more than 50 systems, and 100 different people use this system in order to help protect children at risk. Just one very important use case for MarkLogic that's not necessarily just a customer. Another customer in the UK is the Department of Communities and Local Government. They also use MarkLogic to consolidate all of their systems in order to be able to effectively rehouse the homeless, to distribute funding, as well as manage all their social housing within the department. And then the final one that I've got to talk about is Aetna, who built a HR system that consolidated the over 300 different HR silos across their business, so they can get a consolidated, consistent view of the HR activities right across the organisation. And it actually delivers over 200 different outputs. And it's so successful at Aetna that they're actually building a second project based on MarkLogic. So as you can see, there's many different customers solving many different business problems, complex business problems, using MarkLogic, using the capabilities, the agility, the ability to just bring data in and model as required to solve these complex problems. In all of them, the thing that brings them all together is that all these customers had disparate, disconnected data silos, where in order to get an answer to a question, they had to go and pick a piece of data out of here, a piece of data out of there, a piece of data out, and try to bring them together. Whereas with MarkLogic, they can bring that consolidated or consistent view back together. So we at MarkLogic look forward to discussing how we can help you solve complex business problems. And I can see I've gone a bit fast. So I'm happy to take questions if anyone has any questions.
Could you sing and dance about Macquarie a little bit?
Okay. Yes, I can talk about one of the customers that I'm working with in Sydney. It's a financial services customer. It's international, based out of Sydney. They primarily deal with investment and personal wealth, as well as foreign exchange and foreign stocks. Have a very large investment in Postgres technology or SQL technology. But they also then had over 15 data warehouses across the organisation. Presented a huge problem for them, both in maintenance and change, as well as just the licensing costs of these systems and the infrastructure required to run them. In July of last year, they went to market on their own to research NoSQL technologies. They went right through the market and they decided on MarkLogic. And the reasons they decided on MarkLogic is because of our enterprise level capabilities around transaction asset transactions, the security, our ability to scale out and scale in, all based on commodity hardware, and the fact that we could do both XML and JSON as first-class citizens within the database. So that was in July. From July, they went through the whole procurement process, they went through some proof points, they went through prototyping, and then in April of this year, they actually went live. So that's how fast of this huge international organisation that currently had 12 data warehouses. They went live with their first application within, 6 months. And that is not a small application. That is a transaction store or a trade store across the whole organisation. So what that means is as the trades come into the organisation, they all flow through this trade store for post-trade processing and consolidation and auditing and regulatory compliance. So it's very, very agile. And they are so pleased with the results, and both with the speed of implementation and the agility with which they've done it, that they're now lining up 10 other projects to do with MarkLogic, ranging from records retention solutions through to control room security, and even actual trading systems. So it's very exciting.
Great. Does anyone have questions for Chris? No?
No.
So I actually don't want to start the closing keynote early because we have another room full of conference attendees in the technical track, and we want to give them a chance to come back into this room and join all of you for the closing keynote. So if you don't mind taking this opportunity to do some additional networking for the next 15 minutes, then we will reconvene in here and start the keynote on time. And thank you again, Christopher.
Thank you.
Thanks.